Today, we're diving into a pretty mind-bending concept for a new kind of AI. And get this, it's inspired not by code, but by the most powerful problem solver on the planet, evolution itself. So just think about this for a second. What if an AI didn't just follow a single, logical A to B to C path? What if it could unleash a whole population of ideas all at once and then let them compete, mutate, and evolve toward the best possible answer? This is the wild idea behind a concept called genetic parallel deep thinking, or GPDT. To really wrap your head around it, picture a swamp that's just swarming with millions of tadpoles. Each one is a little bit different, right? A unique genetic experiment being tested by its environment, and only the fittest survive. GPDT basically says, hey, let's do that with AI. Let's treat every single line of reasoning like a tadpole and a massive, competitive swamp of ideas. To make it even clearer, let's look at the difference. A standard AI? Well, it thinks in a straight line. Now, even some of the more advanced models that explore a few paths at once are really just thinking in parallel. But GPDT, this is a totally different beast. It takes those parallel thoughts and actually forces them to compete and reproduce, just like a biological system. So it's not just parallel thinking, it's generative thinking. Okay, so how in the world would this actually work? Well, if you want artificial evolution, you're going to need some kind of artificial DNA. And that brings us to the absolute heart of this whole system, a concept they call the reasonome. The reasonome is basically the DNA for an AI's thought process. It's designed as this modular, circular genome, kind of like a plasmid you'd find in bacteria. But instead of genes for, say, antibiotic resistance, it's packed with genes for logic, like deduction, induction, or causal thinking. You get a bunch of these together, and that forms the AI's reasoning nucleus. And the structure of this reasonome is just super elegant. It's broken down into three main parts. First up, you have an on switch. When the AI bumps into a problem, this switch flips, and the reasoning process kicks off. Next, there's a regulator. You can think of this as a manager that decides which logic tools are the right ones for the job. And finally, you've got the toolkit itself. This is the toolbox holding all the different reasoning styles the AI can actually use. It's a complete, self-contained blueprint for how to think. All right, so we've got the DNA of an AI thought. But how do you actually make it evolve? The GPDT paper lays out 4 different competitive frameworks, or games, to get this whole process started. The first one is the most straightforward. Think of it like a lone genius. You have a single AI that generates a whole bunch of its own ideas, its reasonomes, and then it just runs them through an internal cycle of testing and refining again and again, getting closer to the best solution. It's evolution happening all inside one digital mind. Framework 2 is where things get competitive. Imagine 2 AIs playing what the paper calls an adversarial tennis match. Each one evolves its own set of ideas, its own reasonomes, and they go head-to-head trying to find the best answer. Here's the catch. The loser gets one and only one more round to come up with a better answer, or it's out. That constant pressure is designed to force some seriously rapid evolution. Now, Framework 3 blows this up into a full-on tournament. You have a bunch of AIs competing, and the winners move on. But here's the really cool part. The winner can actually absorb the best reasoning strategies, the best genes, from the loser's reasonoma. This is just like what happens in biology, allowing the best ways of thinking to spread and accumulate, creating an even stronger competitor for the next round. And finally, Framework 4 is the self-play model. This is like a perfectionist AI that's also its own toughest critic. It just keeps generating solutions, evaluating them, and iterating on its own reasonomes over and over and over again until it hits some predefined level of good enough. It's basically a self-driven hunt for the perfect answer. So these frameworks, they're more than just ideas. An AI that can actually evolve its own way of thinking would have some really profound implications. I mean, it would open up doors to both incredible promise and, frankly, some unprecedented peril. On the one hand, the good stuff is staggering. Think about hyperlearning, an AI that could master entire fields of science at a speed we can't even imagine. Or in medicine, it could simulate millions of patient profiles to test countless treatments all at once, maybe finding cures in just a fraction of the time. It could design smarter cities, revolutionize farming, or use swarm intelligence for defense. It's a vision of AI as the ultimate partner in solving our biggest problems. But every single one of those promises has a dark side. The same evolutionary power that could design medicines could also design new bioweapons. An AI that can optimize a city could also be used for mass surveillance on a scale that's hard to fathom. And just the raw computing power needed to do all this, the environmental costs would be absolutely massive. This is a true double-edged sword if there ever was one. You know, the paper itself says it best with a line, "With incredible deep thinking powers comes great responsibility." It's a pretty clear nod to the huge ethical tightrope we'd have to walk if this technology ever actually becomes a reality. So, after all this futuristic, mind-bending stuff, let's bring it back to Earth for a second. Where does GPDT stand right now? Can you go out and use this thing? The short answer is no. For now, GPDT is still a hypothetical concept. It's a brilliant, incredibly detailed blueprint from Grandma's Boy Labs, but that's what it is, a blueprint, on paper, waiting for the time, the money, and the resources to actually be tested in the real world. And that really leaves us with a final and pretty challenging thought. A concept like GPDT pushes the boundary of what we even think of as AI, moving it away from just pure math and closer to a core process of life itself. So the question we have to ask is, if we build an AI that can evolve its own thoughts, are we just making a better tool, or are we creating an entirely new form of life?